What's up guys, it's Lionel the Builder back again with another video, and today I'm very excited to go over every React concept explained in just 12 minutes. This is an awesome video by Code Bootcamp, and I've been using React for about 5 months, but I still have a couple different holes in my knowledge where even though I've used everything, I've written context, I've used use effect hooks and all of that stuff, I don't necessarily understand it to the masterful level that I want to. And us as junior developers, as newer guys on the scene, we need to always try and strengthen our knowledge. So I'm going to title this something about it being for beginners, and hopefully with my own commentary as well as looking at my code mentor that I created in ChatGPT, we should be able to help a lot of people out there strengthen their knowledge. That's what we're aiming for. Without any further ado, let's get into it.
React is a JavaScript library full of fancy terms like reconciliation, composition, and error boundaries. But what do all these terms actually mean? Let's start from the beginning with components. Components are the building blocks of every React app. They allow us to make all the visible parts of our applications, like buttons, inputs, or even entire pages. Just like Legos, you can use components as many times as you want. Every React component is a JavaScript function that returns markup. But since React is a JavaScript...
And now, of course, that's self-explanatory. We all know that, right? For the most part. But in case you are completely new, what this means is basically that your website is one big Lego statue and components are each individual blocks. And with React, we're able to create those separately and then reuse them later on, which makes it simple to make further changes because you only have to change things in one spot. And every place that you have reused that component, say it be like a drop-down menu that changes your role or something like that, whether you're a user or an admin, on all the different parts of your website, you would just have this one component to change, then it would automatically update and render from there.
JavaScript library, React components don't return HTML markup. They actually return something called JSX, which is JavaScript in disguise. JSX is optional, but the alternative way to make user interfaces is with the function createElement, which gets annoying to write pretty fast, so everyone just uses JSX.
Right, and I always look at JSX like JavaScript mixed with HTML. That's how I understand it in my mind, at least, because it's mostly for the front end.
Since JSX is JavaScript, you can't write attributes like you would in HTML. You have to write them in the camel case style. That means HTML attributes like class become class name. Unlike HTML, which is static and unchanging, the benefit of using React is that you can use dynamic JavaScript values in your JSX. If you have data, you can display it in your JSX using curly braces. Curly braces accept values like strings and numbers directly. You can use them to make your attributes dynamic.
And by dynamic, he means that now your front end can change, right? So you can create a button that you can hold state on it, like a score, and whenever you click that button, it goes up. Just all straight up from the front end with React and a component. That's what I mean by dynamic values. It's changeable.
And you can style React elements using a JavaScript object within the curly braces. Since JavaScript functions can only return one thing, in React, you can only return one parent element from a component, so you can't do this without getting a big error. We could fix this by wrapping these components in a div, but maybe you don't want to add another element to the page. Instead, you can use an empty component called a React fragment. Okay, but what if I want to pass data into another component? For that, you use something called props. To make a prop, create a name on the component you want to pass data to and set it equal to some value. And that's it. You can then use that prop in the component you passed it to. Props refers to properties on an object, which is what you get in the parameters of each component. To use the prop...
You guys got that, right? So props, now you can, let's run it back a little bit.
Called a React fragment. Okay, but what if I want to pass data into another component? For that, you use something called props. To make a prop, create a name on the component you want to pass data to and set it equal to some value. And that's it. You can then use that prop in the component you passed it to. Props refers to properties on an object, which is what you get in the parameter.
Interesting. I always looked at those as arguments, because I mean it's basically the same thing with the function, right? But yeah, even though I've been using this for a while, I never really thought about that's actually a property, and in order to, now you're returning the value props.text, whatever that is. So you could literally type anything in here and it's going to return your h1 text here.
Parameters of each component. To use the prop, take it from the object like a normal JavaScript property. Think of them like custom attributes you can add to any component. So wait, can you pass anything as a prop? Yes, you can. You can even pass other components as props using the children prop. If you make opening and closing tags for a component, you can pass other components in between them. These passed components are called children, and you can access them on the children prop of the parent component. And it's great for something called composition, which is about organizing our React components in the most optimal way. The children.
I guess this would be a good time to tap into ChatGPT, right? So I'm going to ask, can you explain children passing props to a child component from a parent? Can you explain passing props from a or to a child component from a parent, and what's the purpose and an example of how that would look like? One thing that I don't like about tutorials is when they don't show what that actually looks like on a website. Let's see. Certainly, passing props in React is a fundamental concept that allows you to pass data from one component, typically a parent, to another component, typically a child. This mechanism is crucial for the component-based architecture of React, and it helps maintain a unidirectional data flow, which simplifies the data management across your application. Purpose of passing props: reusability. By passing different values as props, you can reuse the same component with different data, making your components more versatile. Simplicity. It simplifies data management by keeping the state in parent components and passing it down to the child components as props. This keeps the child components pure and deterministic, which makes the application easier to understand and debug. Unidirectional data flow. React embraces unidirectional data flow. Data in a React application flows from parent to child components through props, which makes the flow of data predictable and easier to debug. Now, an example. Imagine you're building a simple website that displays a greeting message. You have a parent component, app, that contains the message, and a child component, greeting, that displays it. So let's see, we're importing React, import greeting from the greeting. So this is like so this is the child component, greeting, which is separate from this parent component, app, and that's somewhere else. That's why you're importing it into this file. You know, we talking to everybody out there. I know some of y'all like, duh, bro. But anyway, function app. So this is the main component here that we're building now. Const message. So the message is welcome to our website, which is going to return, and this is where your JSX comes into play. A div, greeting, message. So here's the child component. Greeting, message. Now you can pass the data as a prop. So message, I imagine, is inside the child component. Okay, so message is a prop inside the child component. Okay, so that does make sense. So now, yeah. So that way you would, So yeah, we see it, but in this example, the app component holds the message state, welcome to our website. So no matter what, that'll always, from the parent, I almost said dad, from the parent, it's always gonna say welcome to our website, right? But then greeting, now you can change the message here within the prop. Welcome to our website, and passes it down to the greeting components as a prop named message. The greeting component receives props, an object containing all the passed down props, and uses it to display the message. Oh, so the child is actually displaying the message. It accesses the message using props.message. So if you wanted to change it, you would actually change it in the parent then. Const app message here. Slightly confusing still, but yeah, okay. So if you wanted to change the message, you would have to change it in there. So the greeting is really the child. The parent is really just the structure of the app that holds the message. Hopefully I didn't explain that too confusing. I'm understanding it, but my explaining is not as good as my understanding. The greeting component receives props, an object containing all the past props, and uses it to display the message. It accesses the message using props.message. So when the app component renders, it will display welcome to our website through the greeting component. This demonstrates how data is passed from a parent component to a child via props, enabling the child component to display data managed by the parent. Okay, yeah. So the greeting component is simplified. All you have to do is import React, have the function greeting props, which is returning the props.message. Now export default greeting. So that's interesting. I'm surprised that you don't have to import the app.js into here. Why don't you have to import that into here? I guess, let me ask that. Why don't you have to import the app.jsx into the greeting component if that's the one that's passing down message? That's a question, right? Is anybody else out there wondering that? In React, the flow of data, including props, is unidirectional, meaning it goes from parent to child components. This architecture doesn't require child components to have knowledge about where the props come from. Okay, which parent component is passing the props down? This is by design to ensure components are modular, reusable, and their dependencies are minimized. That's why the greeting component doesn't need to. Okay, so that's the whole purpose of the unidirectional data flow. It's because of that. Interesting. So it's isolation. Each component is designed to be isolated and reusable. It should not have to know about the broader context in which it's used, including the parent components that passes the props down to it. This makes components more modular and easier to maintain or reuse. So that's the unidirectional data flow. React's data flow is from parent to child, not the other way around. So no matter what, it's already going to get everything that the parent has. That makes sense. This makes components more modular. When you import and use a component within another, you're effectively telling React this component will be placed here and might receive some props. The child component doesn't and shouldn't care about the specifics of the parent component that's rendering it. Props as an interface. Think of props as the interface between components. The child declares what props it expects to receive, often documented via prop types or TypeScript interfaces. True, that's how it knows what to expect. True. And the parent component passes the appropriate data. This contract allows components to communicate without being tightly coupled. That's the component hierarchy. In a typical React application, there's a hierarchy of components. The index.js file, true, usually renders the app components at the root, and the app components can render the other child components. These child components can render their own children, and so forth. This hierarchy enables a clear structure for the flow of props. So imagine greeting as a reusable component that displays any message you give it. You might use it in app.jsx to say welcome to the website, but in another part of the site, say contacts page, you might use the same greeting component that says thanks for getting in touch. If greeting needed to know about each component that might render it, it would quickly become tightly coupled to those components, reducing its reusability and increasing the complexity of your code base. So by designing components to be ignorant of the parents, React keeps your UI modular and flexible. This approach encourages development of simple, testable components that can be easily reused across your project. Okay. Sorry for veering off there, but that's what we're trying to do. We're trying to really zoom in and fully understand everything. And I just had a small area of confusion there that I needed to fill. So hopefully that was helpful to somebody else. Let's keep going.
Children prop is really useful for creating layout components when you want your children to have the same common layout. The key prop is another built-in prop to React. And no, unlike the name implies, it doesn't unlock anything interesting. The key prop is used so React can tell one component apart from another. usually when you're creating a list with the map function. A key is just a unique string or number to identify a component. You'll usually know when you need to add a key.
So basically like an ID, but a prop.
Because React will warn you in the console. Fortunately, if you don't have a unique value for each item, you can always use the current index from the map function. But how does React take all my amazing code and make it display something in the browser? That process is called rendering. React does this for us, but it's important to know how it works because sometimes we can do a bad thing and cause it to infinitely re-render, which crashes our app. The way React knows how and when to render our application is using something called the virtual DOM, also known as the VDOM. Okay, but what does DOM mean? DOM stands for Document Object Model, which is what every browser uses to model all the HTML elements on.
You guys know about the DOM, right? Anyone who took an HTML, CSS, JavaScript course would know about this here. But it's still good to take a look at it and to remind ourselves.
On a web page, and when you draw it out, it kind of looks like a tree. Here's the complete rendering process in React. If the state of our React app changes, then React updates the virtual DOM, which is quicker to update than the real DOM. Then, React uses a process called diffing to compare the updated virtual DOM to a previous version to see what's changed. Once it sees what's different, React uses a process called reconciliation to update the real DOM with the changes that it found. Whenever someone uses our app, tons of events take place like clicks, mouse movements, and key presses, many of which we need to detect. Event handling is how we take those user events and do something with them. React has a lot of built-in events such as onClick, onChange, and onSubmit. These three events are ones you'll probably use the most. If we want to alert users when a button is clicked, we would add the onClick prop to the button and connect it to a function that would show that alert. To manage data in our React apps, we need to use state. Not that kind of state though. State is like a snapshot from a camera. It's a picture of our app at any given time. To manage state, we also can't use JavaScript variables. They don't cause our app to re-render.
You guys got that right? The event lister thing is just listening for events. That's why I didn't pause it. It was a little self-explanatory. State, I think, is worth a pause. And he said it's a snapshot, which makes sense. But I usually remember state as like a score. Like how he says, let likes equal 0, const me equals cool, not simple variables. Okay, I don't know what he means by that. But state would be like, if you're keeping track of a score, you're going to have it as 0, but 0 is not necessary. 0 is just the variable. State would be the ability for that 0 to go up, right? I almost said or down, but most games you're not going to lose points. But yeah, it's possible. So state is just the ability to hold information. I could be wrong about that. Maybe is that worth an ask here? Can you explain state simply with an analogy? Let's just see, while we're at it, right? Sure, think of state in a React component like current condition or mood of a person. Just like a person's mood can change in response to different events, the state component can change based on user interactions or other factors. Analogy would be a light switch. Imagine a light bulb in a room controlled by a light switch. The light bulb represents your React component, and the light switch represents the component's state. True. The state has two possible values, on and off. So the switch itself, like on and off, is not the state, right? It's the switch. Now you have the ability because of the switch. So the initial state is off. When you first enter the room, the light is off. This is like a component's initial state when it first renders. For example, you might have a useState hook in your component set to false, indicating that the light or feature in your app is off initially. True. Changing the state, switching on. If you want the room to be brighter, you flip the switch to on. This action is similar to updating the state in your component. This is setting the useState value to true. So you could have like user is logged in as false. And that would have the state of the user being signed into the site off. And then as soon as they sign on, right, that would change it to on, causing it to render, and then whatever changes you want to make depending on how you built the site would take place there. So that's me skipping through this and taking over, but the wrap it up analogy it said was initialization is setting up an initial state of the light is off. Updating changes the state in response to some action, flipping the switch, so that would where our event handlers and stuff like that come into play. And then reflection, the component reacts to state changes to turn it on and off, and it would re-render however you set it up with the JSX in the return statement of whatever component we're in. Remember, state is what allows your React components to create dynamic and interactive user interfaces, reacting to user inputs and other actions, just like the light bulb reacts to switch being flipped. Is that why they call this React?
Instead, we use special functions like useState and useReducer. useState takes an argument that serves as the starting value of the state variable, which is like.
I want to search useReducer so bad, but I'm pretty sure that just means to reduce, right? But man, we're not supposed to be assuming anything. So how about useReducer? I'm sorry, y'all. I know we just stopped, but let's extend the light bulb analogy to explain useReducer, a React hook that's particularly useful for managing more complex state logic. Extending a NAS. Now it's a smart lighting system. Imagine now that instead of a simple light bulb with a switch, you have a smart lighting system in your room. This system can not only turn the lights on and off, but can also adjust the brightness, change colors, and set lighting modes like reading or party or night. Managing this with a simple on and off switch with useState becomes cumbersome because the state is more complex, involving multiple aspects. So that's where useReducer comes in handy in React. Akin to upgrading to a smart lighting system. Smart lighting system complex. See, so I was wrong. It wasn't just reducing. Smart lighting system, complex state management. Just as smart lighting system takes commands like increase brightness, set to party mode, and updates the room's light accordingly, useReducer allows you to handle complex state logic by dispatching actions that describe what need to happen, like increment counter, change color, actions, it's commands to the system. In the smart lighting system, you might have a remote or app with buttons with different actions, turn on, brighter, change color. In a React component using useReducer, actions are objects that describe what needs to change. For example, type toggle could represent flipping on and off. Type brighten could indicate increasing the brightness. Reducers the system's brain. The smart system has a central control unit that decides how to adjust the lighting based on components. In React's useReducer function plays this role. It takes the current state and action as arguments and returns a new state. For instance, it knows how to handle an action like the brighter, increasing the brightness level in the state. Dispatch is sending commands. When you press a button on the smart system's remote, you're dispatching commands. Similarly in React, using the dispatch function provided by useReducer. So dispatch is a function provided by useReducer that you send actions to the reducer function to update the state accordingly. Let's look at an example. I had to make sure my face isn't in the way of that. Let me scoot over just a little bit. All right. Okay, example. Let's say you're managing a UI component state that can be in multiple modes and also turned on and off. All right. So const, I hope y'all can see this. Can I zoom in? So const initial state is on, false, mode normal, function reducer state action, switch action dot type, case toggle, return state is on if it's not is on. Set mode, return state mode action payload, default throw new error. Function smart lighting control, const state dispatch equals useReducer, reducer initial state. And now here's all of the JSX returned to show to render. Just as the smart lighting system provides a sophisticated way to manage a room's lighting, useReducer offers a more structured approach to managing complex state in your React components. It allows you to centralize state logic, making it easier to understand and maintain, especially as your application grows and evolves. Okay, so basically this is just adding extra cases to switch through and adding extra functionality to our light switch or to the state of whatever you're doing. That's where useReducer comes in, because you can do more actions. Like here, you're just programming more situations into the situation, if you will. So let me zoom back out to where it's comfortable and continue.
Likes in this example, and returns an array containing the state variable and a function to update that state. Using our button example, we could also update the number of times the button's been clicked with the update function, setClicks, and display it in the button with the state variable likes. Controlled components use state values to have more predictable behavior. Here's an example of a controlled component where the value typed into the input is being put into state and controlled by the state variable value. Here's how it works. The user types, and setValue puts what the user typed into state. The state value is then updated, and finally, the input uses that updated state as its value. Controlled components are a great pattern to use because if we want to change the component's behavior, we just need to change the state that controls it. useState is an example.
That was self-explanatory, right? You guys got that. Whatever the value is, you set the value and use state, and then it will be displayed here. On change, that's the event listener. That's listening for the change, if the button's clicked. Is that what it was?
Behavior.
Whatever makes
we just
the
need
change.
To change the state that controls it. useState is an example of a React hook, which allow us to hook into features such as state within function components. There are 5 main types of hooks. State hooks like useState and useReducer help you manage state within React components. Context hooks such as useContext let you use data pass through React context.
Context helps you use data passed through React context. Right, so that can make it now global within the entire project. Managing state with that first hook.
Ref hooks, such as useRef, let you reference things like HTML elements. Effect hooks.
useRef helps you reference things like HTML elements. Wonder what else can you reference?
Like useEffect, let you connect with external systems like browser APIs. And performance hooks like useMemo and useCallback, which can improve performance by preventing unnecessary work. You'll use all of these hooks at some point.
Okay, now I want to go zoom in on all of these, but I see we're already at almost 30 minutes. I don't want this video to be too long, but if I've shown you guys, I've shown you guys the workflow, right? So if you need to zoom in on any of these, I will probably later on, but I want to continue because I want to finish this entire video at least. And I've got this bookmarked. Links in the description too, so you guys can go back here without my commentary when you want to, but let's continue just to make it through. We still got like 4 more minutes left. So
but the majority of the time you'll likely use just 3 hooks in your React components: useState, useEffect, and useRef. When you think of the word purity, you might think of something like purified water. Purity is a term used to describe how React components should work.
I'm surprised. He said that those were the 3 ones that you will use the most, but for me in my project that I've used so far, I've had to use context an awful lot. And like I said, that's a way of making things global. Like I had to make a project context for a project management app. It's a company context so that every user's company can be seen globally throughout the entire thing, and then user context for the user document as the person who logged in. So I thought that would be one of the 3 majors, but useState for sure, useEffect for sure, and what was the
useRef.
useRef. I don't know about that.
When you think of the word purity, you might think of something like purified water. Purity is a term used to describe how React components should work. But this type of purity is more like how mathematical formulas are pure. Pure React components mean that the same input should always return the same output. To keep a React component pure, they should only return their JSX and not change any objects or variables that existed before rendering. The cup component in this example is impure because it changes the variable count during render, which exists outside the component. This leads to the JSX having the wrong output when it is used more than once. To help make sure we don't run into errors like this, we can use something called strict mode. Strict mode is a special component which tells us about mistakes as we develop our React apps. It's really convenient because it's just a component we usually wrap around our app component, and it'll tell us when we really shouldn't do something. But what if we need to do something outside our React app? Your app might need to talk with the browser API or make a request to a server. If you do have an external system, you're going to need a way to step outside of React. Effects are code that reach outside of our React application. Usually effects, also known as side effects, can be done within event handlers. For example, to make an HTTP request when you submit a form.
Oh, right. Yeah, you definitely use that a lot. I'm sorry. Before I said that you don't use that often. Yes, of course you would.
Click on a
My
button.
bad.
If you can't run your effects within an event handler, then you can run them using the useEffect hook. For example, a common pattern is to fetch data when components first load with the useEffect hook. Like effects, sometimes you want to step outside React and work directly with the DOM. To reference an actual DOM element, you can use what's called a ref. You can create a ref with the useRef hook, and to get access to a DOM element, use the ref prop on any React element. For some tasks, such as focusing an input, it's much easier to reference the actual DOM element instead of attempting to do it the React way. Context is a powerful way to pass prop data through your app's components. Most React apps have tons of nested components. To get data down multiple levels involves passing the same props through components that don't actually need it. Context lets us jump through the component tree and use data at any level without making props. To use context, you first create context in a parent component, then wrap your parent component in a special context component called a context provider.
Right.
Put the data you want to pass down on the provider, and finally access that data in any child component with the useContext hook. Portals, on the other hand, are kind of like context but for components. Portals let you move React components into any HTML element you select. Portals are great for components that can't be displayed properly because of their parents' component styles. For example, for displaying modals, drop-down menus, and tooltips. To create a portal, just use the createPortal function, pass your component to it, and choose
You can create a portal, bro? That's some Marvel shit.
the HTML element where you'd like your React component to appear. Suspense is a special component that helps you handle loading a component or its data. Suspense is helpful for components that take some time to fetch data. It provides a better user experience to show a fallback component like a loading spinner until the data is available instead of nothing. Suspense is also useful if you're lazily loading a component, which lets us load a component only when it's needed. Since React apps are all JavaScript, errors that happen during rendering can totally break your app. Error boundaries are components that let you catch app-breaking errors and show a fallback component to tell the user about what happened. For example, our app will crash if we run this code because it throws an error when there's no user. To prevent our app from crashing, we'll first add an error boundary to display a fallback component with a more helpful error message to be displayed to the user. Now, if you really want to dive deep into React, I've put together a complete bootcamp to help you master every one of these concepts from front to back. You can get started now at reactbootcamp.dev.
That's what's up. If you guys, go there if you guys want to really lock in. But where I stopped explaining and stopped digging in, I think I'm gonna make a part 2 to this. If you guys find value in that, drop a comment and let me know if you would like to see part 2 of this. Regardless, I've got this bookmarked. I'm gonna go watch it again, and wherever I feel like I don't have the proper understanding of something, I'm going to talk to my GPT mentor, maybe even hop into the React documentation to try and figure this stuff out more. And I thought if I did this live, being a little bit vulnerable, showing how I don't understand everything perfectly, but still showing you guys that I'm an employed full stack software engineer with multiple contracts and clients aside from the main startup that I work for. So do not wait to tell you know everything masterfully to start building stuff. Build as you go, work as you go, learn as you go, grow as you go. That's what it means to be a software engineer. Please like, share, subscribe. All of my links are inside of the description. Shout out to the school, shout out to Discord, shout out to Software Developer Academy. I'm Lionel the Builder, and I'll see you next time. Peace.